In this video, let us see some important questions on application software and system software from Module 1 of C programming. Question number 1. What are the differences between compiled and interpreted languages? Give example for each. In compiled language, entire source code is compiled into machine code before execution. But in the case of interpreted language, the source code is executed line by line. The interpreter reads each line of code, translate it into machine code, and then execute it immediately. Once the program is compiled, it can be executed at any time without recompilation. Interpreted programs are executed by processing each line individually every time they are run. Execution is faster in the case of compiled program because it generates optimized machine code before the program runs. Execution is slower in the case of an interpreter due to its line-by-line translation and analysis during runtime. In the case of compiler, errors are shown after the entire program is checked. On the other hand, interpreters promptly report error for each line during execution. C, C++, Rust, etc. are examples of compiled languages. Python, Ruby, JavaScript are examples of interpreted languages. Differentiate between system software and application software. System software is general-purpose software that manages and controls the computer's hardware and provide essential services for the operating system and other software to run efficiently. Application software is specific-purpose software designed to perform particular tasks or solve specific problems for users catering to various needs and functions. Examples for system software include operating systems, device drivers, firmware, etc. Examples for application software include word processors, browsers, photo editors, etc. System software handles tasks like memory management, process scheduling, and hardware communication. Application software offers specialized functions like document editing, data analysis, entertainment, etc. System software operates at lower level, interacts with the hardware, and supports the overall system functioning. Application software is used directly by the user to accomplish specific goals or tasks. Users do not directly interact with system software, it works in the background. Users interact directly with application software for various activities. Differentiate between high-level languages and low-level languages. High-level languages are more human-readable with English-like syntax and meaningful keywords. Low-level languages are less human-readable, often using symbols and mnemonics closely related to hardware operations. Examples for high-level languages are Python, Java, C++, Ruby, etc. Examples for low-level languages are assembly languages, machine languages, etc. High-level language offers a higher level of abstraction, focusing on problem-solving and logic rather than hardware details. Low-level languages provides lower level of abstraction, requiring the programmers to manage hardware-specific detail. High-level languages are more portable as programs can be written to work on different platforms without major modifications. Low-level languages are less portable as programs are often tied to a specific hardware architecture. High-level languages offer faster development due to built-in functions and higher-level constructs. Slower development as programmers need to manage memory and hardware operations manually in the case of low-level languages. Generally, slower execution as it involves translation to machine code and additional layer of abstraction in the case of high-level language. In the case of low-level language, potentially faster execution due to direct control over hardware resources. Easier maintenance due to higher-level abstractions and better readability for high-level language. More challenging maintenance due to hardware-specific code and lack of readability in the case of low-level language. These are some of the important questions. Thank you.